Sean McVeigh, National Training Coordinator at Consolidation Center. Today's webinar
momentarily on web services.
What is a web
service? How can we use it with full survey?
And our speaker today
is Jennifer Sweet, qualified as the NGMC.
She's going to be
Her
background to you. Who she is.
And her topic today.
I want to remind everyone that today's webinar is being recorded and that we are broadcasting. So we'll not take any audio comments from participants today. If you have a question, you'll have to use the Q&A button at the top of the live meeting window. It says Q&A, and you can submit questions. And then there's a panel of NGMC staff that will queue up your questions for our presenter, and they can answer them at that time. So with that, I'm going to go on. One more thing. Today's session is being recorded, and that recording will be made available online by selecting webinars, presentations, and training sessions online at usda.gov/education/resources/videos/HTML. All right.
With that, Jennifer, I'm ready to turn it over to you.
Thanks very much, Sean. Good afternoon, everyone. Yes, the topic is on web services today, and I am at the National Geospatial Management Center here in Fort Worth. Just a little bit about me.
Jennifer, I might have to mute your microphone. Yeah.
Is that better?
That's better, yeah.
My name is Jennifer Sweet, and if that name doesn't ring any bells for you, perhaps you might remember me as Jennifer. So I've been with the agency as a full running for the past 4 years. Nearly 5 of those were in West Virginia, where I'm from, and I moved here to NGMC or NGMC in Fort Worth several years ago. Sean mentioned to me that he liked to put a photograph on the advertisements that he sent out to everybody, and I neglected to send him a picture. So Sean, here's your picture. And I have the old person on the right. Sometimes it's nice to be the 7-year-old. That's my daughter. It's the first day of school. So just so to help you put a face with the name. If you have any questions at all during the webinar today, use the live meeting Q&A link that's on the top of the screen. Send your questions at any time, and I will do my best to leave some time at the end to answer. If you have any questions after the webinar, please send me an email at the following address, or you can call me at the phone number listed there. I am always envious of folks who have questions right when the presenter stops speaking, and I'm always envious of that. I just don't assimilate the information quite that quick, and 3 hours later I have 10 questions. So if you have the questions, please send me the email or give me a call. What exactly is a web service? Well, according to Wikipedia, it's a method of communication between two devices over the World Wide Web, or WWW. In other words, you can get data on your machine in your office from a computer located here in Fort Worth over the internet using a browser like IE, in this case Internet Explorer. There's also Mozilla, there's Firefox, there are several other browsers that are out there. All you need is a URL, or a Uniform Resource Locator. So if I type in the following URL in a browser, and yes, I give you it's a long browser, or long URL, it's going to lead me to this web service. This is the NAPE CIR web service that runs here at NGMC in Fort Worth. Back up and we'll talk a little bit more about the URL. There is that long address there, and we're going to shorten it down to talk about just ncgcws.ftw.nrcs.usda.gov. It is a fully qualified address, and that's called the host name. The ArcGIS part of that URL is the instance. The rest part of that is the protocol. Services just because they're services. So if we take a little bit of time and bring this up in IE, okay, and where it says ArcGIS Services Directory, That directory allows for the browsing of the contents on that host or on that server and obtain information about the services that are listed there. For the current version, it gives you the version of ArcGIS. Also lets you view the footprints of data in this case, Google Earth. It's a downloadable KMZ file, and I don't have Google Earth installed on this machine, so we couldn't quite see that. These are the folders containing the services, and they're expressed as themes. You can pretend that this is the SGO data drive on your machines in your offices. Also, take a look at the supported interfaces. Those last two, Sitemap and GeoSitemap, are Google interfaces. The other two interfaces, REST and SOAP. They're both protocols for exchanging information through web services over a computer network. SOAP. I wouldn't have thought this is what SOAP stood for. Simple Object Access Protocol. It's a specification or a standard that's used to exchange the information by XML. A couple advantages of SOAP. It's very versatile. It uses the HTTP protocol to tunnel through the firewalls. You can pretend that we're beginning to talk about security here when we talk about tunneling through the firewalls. Some of the disadvantages, though, of SOAP are that they have slower, or it's a slower response, so it's going to give you a little bit of a slower web service. The other protocol is REST. REST is more of a style that consists of a series of clients and servers. So the client initiates the request, it's sent to the server, that server processes the request, and then it's going to return to you the appropriate response. So the advantages of REST, it's very lightweight, very easy to build. However, there's not a common standard. The SRI has just submitted the REST standard for certification through the Open Geospatial Consortium. REST is also the most common web service design that exists out there today. Just for fun, if you were to do a really quick Google search for ArcGIS REST services, you can type that into the search bar, or you can actually go in and limit the domain and say that also. You're going to get returned several different things. This isn't NRCS, this isn't USDA. These are just other names out there, host names and other services if you just search on these two terms. So the first one is a NOAA REST service. The second one, not really sure what that IP address, but since it's got weather in there, well, it could be NOAA, it might not be. The third one there, something on the national map. The fourth one, Geocommunicator, that's a BLM service, and you can actually access the PLSS web service through this link. So just go out and take a look at those. They're highly searchable. You're going to see all kinds of things that are going to get returned. A web service doesn't mean that you have to serve data that can be consumed in a GIS. There are several commercial companies out there, just to name a few, Twitter, Flickr. They have web services, they just don't contain geospatial data. We're going to focus specifically on the types of geospatial web services today. You create a map in ArcMap. When you create that map, it means that it's saved with an MXD extension. That's the map. Published to the web through ArcGIS server. And it then becomes a web map service, or WMS. So if you've heard that term, web map service, that's where that comes from. The map then, from that service, can be used in web applications. You can put it in ArcMap, or you can use it in other applications also. So if we take a look at the web map service, the following URL displays this page of folders. We looked at this a little bit earlier, but we're going to look at it more in depth right now. So the folders, each folder contains themes of web services. There can be different types of services. We're going to talk about a map service. We've done that, the web map service. We're going to talk about that some more. Geoprocessing service, an image service, all different types of web services. So let's look at the folders a little bit more closely. In this case, I'm going to look in the Government Units folder. And when I select that, the second part of that screen pops up, and I get all of the services that are listed in the Government Units folder. You can tell that these are map services because in parentheses on to the right, they say that they're map services, or map server, excuse me. A little bit about the naming convention of those services. We try to follow really hard the USDA SCA Geospatial Dataset File Naming Standard. That really does exist. The standard name tries to tell you what the theme is, what type of features are in the dataset, whether it's a point, a line, or an area, the spatial location or the extent, and sometimes you can have a file extension, not always. So in this case, we're looking at the government units, SCA, Service Center, A, it's an area, and its extent is the U.S., so we can gain that information through the name of the feature layer, excuse me. So in this case, A means polygon, delta line, the U.S. denotes a service for the U.S. I'm going to go ahead and select this map service, and I get another screen that opens up in IE, and it's going to talk about the applications that we can view this service in. So you can view this in ArcMap, you can look at it in ArcGIS Explorer, ArcGIS JavaScript, Google Earth, or ArcGIS.com Map. So several places you can look in this layer. You don't have to do it just in IE or just in ArcMap. The service description, the intended use for that service, district locations where customers can access services, future planning. Also, it talks about the layers that are in the service. You're going to get a listing of all the layers that are contained in the service. In this case, we only have one layer, the SCA layer. Spatial reference. There's a URL there to talk about the spatial reference because 4269 doesn't mean much to me or probably to anybody else. So in this case, it is a geographic coordinate system in NAT83. You can also see a little bit about initial extent and the full extent. So a lot of information is included when you click on the service. You can also see what the units of the data are. In this case, they're decimal degree. A little bit of information about the document, what the title, the author, the subject, the keywords especially. Sound familiar? Sound like metadata? Exactly. Metadata are important for all of the data that we're creating. In this case, because we're looking at a map service and we're looking at the MXD, you can actually put more information in the MXD that can be contained in metadata or it can be different than what's in the metadata. If you select the properties on your feature class or your feature layer, right-click and select properties, you have a source information, and there's quite a bit of information that can be put in there, and that's what's usually pulled out and put into the information here. Metadata are important. We don't want to get away from doing that. It also talks about the supported operations that are on this feature layer, so you can look at export maps, you can look at identify, you can look at find. Yes, there is an author name that's on here, in this case, Elaine Ortiz. I'm sure that Elaine would be happy to hear from you about the data. Here's how that conversation goes. Thank you, Elaine. Thank you very much for creating the data that we have in this fabulous web service. So, thanks, Elaine. If we select just the layer, the SCA layer, we actually get another screen that talks about what the display field is. In this case, it's the site name. So when you display this in IE or Mozilla or Firefox, that's the descriptive label that's going to come up. So you know what that is, site name. You also know what the geometry type is. This is a vector polygon feature layer. Talks about the minimum scale, talks about extent. You can also get into the rendering aspect, what it looks like, what the colors are, the display when the map is shown. You can take a look at the fields. All the fields contained in the feature layer, along with the data type and the alias. And query can be supported on this layer. So I'm just browsing through and selecting off of that URL and the REST services, the government units, what we know about the SCS layer. It's on the host called NCGCWS. It's in the government unit services folder. We know what applications we can view the data in. We know that it has district locations. We know that it's in a NAT83 projection. You can do identify, find, export. What the label is going to be when it comes up, it's a polygon, and we know about all the fields in the layer. Never looked at the data yet. I don't know if this is going to work for what I want to use it for, but I've never looked at the data. I've gained all the information just by browsing through the links on the REST services. So here's the data. Brought this up in ArcGIS JavaScript. So this is actually an IE-supported protocol, and you can take a look at this just through your browser and make sure that this is the data that you need for the application or the map that you're building. Now, if I want to add the service to ArcCatalog, this is how I go about doing this. So far, I've just looked at it in Internet Explorer. Now I want to move it into ArcCatalog and ArcMap. So in the catalog tree, there's something there called GIS servers. So you want to expand GIS servers. You're going to double-click and add an ArcGIS server. Use GIS services, select that radio button. We're not going to do manage GIS services. In order to do that, you have to be a system administrator on the ArcGIS server. And fourth, you're going to click next. You want to type in the URL where it says server URL. The second side of that screen, notice REST is not part of the URL. Not really sure why, it's just not. So be careful when you copy and paste here. Then you're going to click on Finish. So the service has been added to the catalog tree. You can see it there, ArcGIS on NCGCWS. And if you expand that or just look at the contents, you can see then all of the folders that are in the service. This is in ArcCatalog. So if you do a comparison, on the left is NIE, if we use that URL, and what's in ArcCatalog, they're the exact same thing. We just looked at them in two different ways, or we've accessed them in two different ways. After you've added it to ArcCatalog, now you can add the data in ArcMap. So I want to click the Add Data button. I want to select GIS servers on the Add Data dialog. Double-click the NCGCWS service. Notice that there's a red X beside it. That red X means that the service is not yet connected. If it's a green X, it means that the service is connected. You can then select the folder containing the services you want to add to ArcMap. We're going to go back to Government Units. That was what was selected, and I'm going to select SCA_A_US and say Add. The data have now been added to ArcMap. So we looked at the data in IE, and now we're looking at the same data in ArcMap. Now that you can use it for geoprocessing functions. Remember we talked about the supported operations? We saw that information where it says export map, identify, or find. Well, identify is one of those supported operations. So inside of ArcMap, I simply clicked on the identify button, that polygon, and I have identify results up. You also have an option of downloading data. Yes, you can download the data from the service, but many times we have much of the data also available on the Geospatial Data Gateway. So if you want to do more with it, or you just want it locally, go ahead and download it from the gateway, and there's the address for the gateway to do that. Occasionally we have other data in the services that you might run across that we built or altered for specific purposes. Most of the time we do this for speed or for locational purposes. We generalize the data. It helps in quickly locating specific areas. They're locational purposes, basically. So when I look at the generalized map, there's one layer that's described as most generalized. You can look at the scale, it's at 1 to 60 million. What you can't discern from, of course, this PowerPoint presentation is the speed at which this displays. This is an instantaneous display because it's been generalized. It's not taking the time to draw in each and every nuance of the Mississippi River or the coastline or anything like that. When you take a look at this, the speed with which this displays is, as soon as you click on it, it shows up on your map. We also have one that's called generalized, and this scales at 1 to 4 million. And you take a look at the representation of the coast. So you can see what's happened there. It's just been generalized so that it will draw more quickly. Another type of web service that exists out there past the web map service is called the Geoprocessing Service. It contains geoprocessing tasks that are accessible by the client, by web-enabled clients. You create this, the tasks are created by publishing a model or a script tool. And then each tool in that toolbox becomes a task in the service. You can do geoprocessing on your machine at your desk through ArcMap. You just have to bring the toolbox up. What's different here is you're invoking the geoprocessing task on the server. So the server is doing the geoprocessing, not your local machine. We actually have a different host name where we have a geoprocessing task or geoprocessing service. You can see that there is NGMC GP for geoprocessing, .Fort Worth, NRCS. So it's another one of the host names that you might run across. Okay. We really would like to do a lot more with the geoprocessing services, and it's something that we're going to look into. We do have one here. You can see it's an elevation tool, and it says GP server. It's a geoprocessing server. Geoprocessing service, excuse me. If I were to click on that back at that URL in IE, I'm going to see that the tool is used for the GeoObserver elevation application. One of the requirements for a geoprocessing service is the task. In this case, the name of the task is the Get Map Service Features. If I select that, get a little bit more information about the parameters that are in this tool or this model, where it says I'm going to choose a source layer, and I'm going to add a point on that chosen source layer, and then it's going to return a result for me. In order to use this, you have to add the geoprocessing service also in ArcCatalog and ArcMap, just like you added the map service. Okay. So the first point there is add the geoprocessing service. I didn't go through the steps in this one, just like we did before when we were adding the map service, but I think that started on about slide 27. So you add it the same way. In this case then, because it's a tool, we're going to open our toolbox. We're going to double click on the geoprocessing service that's been added. Select the elevation tool and click open. So we just added the elevation toolbox. We're going to expand that and then double click on the Get Map Services features. And it brings up the Get Map Service Features dialog box in order for you to input the information. So you've just invoked the geoprocessing tool on the server, and it's not processing on your local machine. There's also something out there called a geometry service. We have one of those available here. Basically, those help applications perform calculations, buffering, or projecting. Something else that we need to look a little bit more into. Other web services, we've talked about map service, we've talked about a geoprocessing service, a geometry service. There's also something out there called a feature service. Those enable editing on a layer. That's a little bit different than just identifying or querying, but when you actually are able to edit the feature. We have one web feature service that we're currently testing. I'd like to do more on this too, and we'll get to that as soon as we can. Other services, there are geocoding services that allow for finding and displaying addresses on a map. There are geodata services, globe services, KML, mobile services, all supported with ArcGIS server. Fortunately, we don't offer any of those services at this time. Spend a few minutes talking about the host. Remember we talked about the host name? In this case, it's ncgcws.ftw.nrcs.usda.gov. Those contain public web services. We have other hosts that you may come across. We talked about that earlier when you did a search on ArcGIS REST services. Probably some of the other hosts that you have come across. GDW Web 1. There's also hosts out there called Image Server 1 or Image Server 2. This is not an inclusive list, but these are things that you might run into. Talk about the services on those hosts. We have approximately 200 web services running at NGMC at any given time. Some of those 200 services are duplicates. We're still supporting ArcGIS 9.2. That's why we have some duplicate services that support data in 9.2 versus 9.3 or 10. Many of the ArcGIS 10 services are in the Web Mercator projection. Web Mercator is what Google and Bing use in their maps, and it's kind of been the pseudo-industry standard is to use WebMarcator. So in order for us to use their services, their data, then we need to have a lot of our data in the WebMarcator projection. WebMarcator was not supported in ArcGIS until 9.3.1. We have data that is in WebMarcator. It will crash 9.2. There is absolutely no doubt about that. We have tried it and succeeded, and we know this for a fact. About those other hosts and those services. If the host name or the service has test anywhere in the name, then don't use it in your map. Some of those 200 services, yes, are duplicates. Some of them are tests because we're testing various options of the data, how to display it, how to render it, how to make it work, and we're also testing some of the services. Yeah, we do know that it can be really confusing to have both test and production services on the same host. We're working very hard to have more room so that we can do production and testing on separate hosts. We're having the same experience as everybody else, but doing more with less. If you notice, it's bolded, it's underlined, it's italicized, it's in red. Have I hit you over the head enough with that? Test. Okay? If it's there, don't use it. Please don't use it. We might have something up on Monday, everything in it might be red. On Tuesday, you go back to that test service, and it says that it's a service for the U.S. There's only 3 states in it. On Wednesday, service might be purple. Thursday, we probably found the other 47 states, but we lost the other 3 states that we had on Tuesday. And on Friday, that service is gone. It's a test service. If you used it in your really smart screaming application and it's gone, we're not really sure we want to hear about that. Okay, it's a test service, folks. Switch gears and talk about image services. We talked about map services, geoprocessing services, geometry service. There's such a thing out there called image service, and it's a little bit different. It provides access to raster and image data. It requires raster or it requires a mosaic data set. It can be used in desktop. We have approximately 100 different image services at NGMC. These are different than the 200 map services. So we're talking approximate 300 services that we have supported out of NGMC. What's the difference between a map and an image service? A map service requires the MXT. The image service does not. If you're serving raster data through a map service that requires an MXT, it will slow the rendering of the imagery data. It doesn't slow the rendering of the vector data, just the imagery data. If you're serving image data through the image service, it does not require the MXT and you can consume it directly. And this will certainly speed the rendering of the data. You can kind of look at this as old versus the new technology. The old technology is map service, the new technology is image service. Then we're going to get to something newer, 10.1.2. In order to use the image service in ArcMap, you have to have something called the image server plugin, and it must be installed in 9.2 and in 9.3. It's available for download. It is CCE certified. Please be careful. You do need separate plugins for 9.2 and for 9.3. Contact your local ITS to have those installed. The plugin is provided in 9.3.1 and it's provided in 10. So if you're going to add the plugin to ArcMap 10, because that's what I have don't have 9.3 anymore. Sorry, folks. In ArcMap, select Customize, Customize Mode, select Commands. Once that loads, you want to select Image Server and go over and select the Add Image Server connection. Left-click and drag it to the ArcMap toolbar. You have to maintain the left click as you're dragging it. Release the left mouse button any place that you want to put it. That's just where I chose to drop that icon, and then click Close on the Customize bar. You have to have the Customize dialog box open in order to move the tool onto the toolbar. Now I've added the button. Now I'm going to add the image surface. So I'm going to select Add Image Server Connection button. I'm going to type in the host name, image server 1. And at the end, it is colon 110, 10010. That's port. Click on Get Services, and then it's going to show you what services are available on image server 1. Going to expand the NAIP, look at select all zones CIR, and select Add. You can add more than one service at a time. You just have to keep selecting and adding. And when you're done, click on OK. In this case, I added the NAIP CIR, image service to ArcMap. One thing I want to point out about this, I believe that this is the only CIR NAIP service that exists. Don't think that you're going to find this anyplace else outside of image server 1. Certainly lots of places have NAIP or have imagery, but not a US-based CIR to NAIP. Let's take a look at the map versus the image service again. The map service is going to require the MXD. Image service does not. We're looking at the raster data through the map service. It's going to require an MXD. It's going to slow the rendering of the data, of the imagery data, but not the vector data. If you're going to do it directly through the image service, it doesn't require an MXD. You can consume it directly. The old versus the new technology again. Yes, that was a duplicate site. I thought it bared repeating. So if we look at the image in the map service, on the left, we're simply looking at the folder called With Imagery, NIE. These are the images served through a map service on NCGCWS. Map service, because of the MXD, renders more slowly. We have these map services that are used mainly to support the clients in ArcGIS 9.2. Once everybody moves off of 9.2 and we move to 9.3 or move to 10, then we'll probably deprecate a lot of these services. These are the images served through an image service on image server 1. The image service, because it doesn't require an MXD, and it does render a little bit quicker. So in ArcMap, the one on top is the map service, has the MXD. The one on the bottom is the image service. I consumed it directly, same data. This is high-resolution data from Alaska. What's coming? In ArcGIS 10.1, remember I said there was something newer? In ArcGIS 10.1, image server is being replaced by something called mosaic data sets. I don't know a lot about that. We have folks here, part of my fabulous panel knows quite a bit about that. But more testing will appear when we begin implementing this. Okay. We're probably also going to find some more duplicate services because we're continuing to support 9.2, 9.3, and 10. Let's talk a little bit now about a caching service. A map cache is the entire map at several different levels or scales. The cache also stores copies of the map images. This is a very effective way to make your maps and make your applications run faster. This is how Google and Bing do this in Google Maps and in Bing Maps. When you pan across and there's an instantaneous display of the data, those maps are cached. It can take a while to create the cache, but the benefits are tremendous in both performance and quality. You've experienced that, something that isn't cached, which were a lot of services that we had before, as opposed to when you go to Google Maps and you pan across and it's quick. In order to do this, you have to create a tiling scheme. Once you cache the images, they're no longer in a GIS format for the data. Instead, they become a picture in either JPEG or PNG format. So it's important to remember that. They stop being kind of raster data and turned into a picture. JPEG format is usually used for imagery. The PNG format is usually used for features that require transparency. ArcMap calls it transparency, and when you get to some other software, they call it opacity. You can create services that have a mix of JPEG and PNG formats. Generally, what you find is, if they're mixed, the JPEG format is kind of the central part of the United States, where there's nothing to see through, whereas PNG data are around the coastlines. the levels of caching. Most of the image services that we have here have around 14 to 18 levels of caching. They can differ depending, of course, on the data and what you intend to use the data for. Not all of them have 14 or 18 levels. We're going to see one here in a few minutes that's just got 9. Okay. So to look at the cache maps, we're going to go back to NCGCWS and select easements. And we're going to select Imagery 2007. The big thing to take home is the red circle there, single fused map cache. It says that it's true. If they're not cache maps or cache tiles, it's going to say false. We've got a good description of what this service is. It's used to support monitoring of easements. Okay. The imagery is from 2007. Another special reference is 4326. This means that it's in WGS 84. Take a look at that URL. If you've got a 4-digit code, then you can find out what the projections are. We'll go a little bit farther down in there. We're going to talk about the levels of detail. There are 9 levels of detail here. Each level has a scale. The one I pointed at here, level ID 4, has a scale of 25,000. And the format is mixed, so it contains both JPEG and PNG formats. Talk a little bit about cached maps. The NAEP imagery collection for the entire U.S. We're not going to talk about NAEP 2007, NAEP 2008, because the year isn't important because not every state is collected each year. We're just trying to get a number for what the entire U.S. collection is. 4-band imagery at 1 meter resolution, 35 terabytes of raw data. That's the entire U.S. collection for NAEP. So 1 terabyte equals 1,024 gigabytes. When you're talking about cache maps, each increase in the scale, example, if you're going from a 24,000 to a 12,000 scale map, it increases storage by a factor of 4. Also increases the time to produce by a factor of 4. It takes 4 times longer to produce caches at 12,000 than at 24,000 scale, and 4 times the storage space to store the tiles at 12,000 than at 24,000. It's another way to describe cost. So there is a cost of doing this, and does it benefit your performance and your speed and the storage capacity? Caching also allows the data to be compressed. So we take 35 terabytes of raw NAEP data, and with caching, you can compress that down to 4 terabytes. The 4 terabytes include 17 levels, with that last level being at 1.2 meter resolution. However, we've got 4 terabytes of NAEP data, and I also showed you NAEP CIR, so that's 4 terabytes of NAEP CIR. Still, 8 terabytes is less than 35 terabytes, so we're gaining something on our storage here. I'm sure at this point in your time you're thinking, this woman is nuts. How are we going to remember all of these darn URLs if she keeps rolling through here really quick? Yeah, there's a lot of them out there to remember. What we've tried to do is collect them all in one spot in an application called GeoPortal, and here's the address to that. It allows searching of the data by theme. This is also a work in progress. Remember, doing more with less. It's a picture of what GeoPortal looks like, the front page. Okay. I've selected data themes, and I think I selected cadastral. In this case, I want to select the Boundaries Map service. So there is something out there, a web service for state boundaries. If I select open, it's just bringing this up in IE. We've looked at this before. So this is the state line US service. It has the most generalized, the generalized, and the states layers. So it's got 3 layers in the service. If I preview it, if I look at the metadata details, and I can also view the metadata in XML format. So you can take a look, instead of typing the URL into IE, you can also look at the data and preview the data in GeoPortal. There's also something out there called a Web API, or an Application Programming Interface. The set of requests, along with responses, usually expressed in an XML format. The advantage of this API, it allows for the combination of multiple services into a new application known as a mashup. Silverlight by Microsoft is an example of an API. One of the great advantages of this web API is it's very quick to stand up. We have used Silverlight API to supply imagery for disaster areas. In 2011, there was Hurricane Irene, and we had both the Mississippi and Missouri River flooding. Yes, we do currently have these services, they'll be turned off eventually. These are only available within the USDA network. You can't find these outside of USDA. This is just an example of the Missouri River Disaster Service. Sorry, folks. What that looks like. A little bit of a close-up. You can check for the visibility of each of those layers. There's a transparency slider so that you can start looking to see what's changed, what it was before on the base map versus what that new image has. And then imagery on different dates. If you looked at this NIE and you selected the service, you can see a list of all the layers that are in the service. There's a mixture of spot imagery, there's a mixture of spot 4 imagery, there's a mixture of Landsat imagery. So all of those layers are in this service. What's coming for services? Outside of those 200 map services and the 100 image services that we have, we're looking to have elevation or LiDAR services. We've got 6 terabytes of data already, and that's growing each and every day. We also hope to have do-it-yourself, publish your own web services. We really hope to do that here within the next year, probably. We've talked a lot about the services that are at NGMC. What are the future plans for the services? Well, all of the services are going to move within the next year. Yes. URLs are going to change, and there isn't any way that we can prevent that from happening. Something out there called the Federal Data Center Consolidation Initiative. The Fort Worth Data Center is scheduled to close at the end of the 2013 fiscal year. The Fort Worth Data Center is not the same as the National Geospatial Management Center. The Fort Worth office is not closing. The only thing that we're closing is the data center services, the hardware, the software, and the services. We'll still be here. If you want more information about the Federal Government Data Center Consolidation Initiative, there's the URL for that. They're talking about consolidating all of the data centers that exist in the government down to just a few. So USDA certainly has some, but when you look at this, you're talking FDA, you're talking EPA, so this just isn't a USDA thing. This is a federal government initiative. So if they're not going to be here, where are they going? They're most likely going to end up at the National Information Technology Center, which is called NITC in Kansas City. There's a location, the URL for NITC in Kansas City. Yes, it's a government facility. So why there and not somewhere commercial? Okay. Well, the reason why we can't do that, at least at this point, is something called FISMA. The Federal Information Security Management Act of 2002 recognizes the importance of information security. It requires each federal agency to develop and document to provide information security for the information that we have and for the systems that support the operations and assets of the agency, including those provided or managed by another agency, contractor, or other source. FISMA defines 3 levels of potential impact on organizations or individuals if there is a security breach. Those are low, moderate, and high. OCIO must make the determination of the impact, the potential impact level of your data. Okay. Yes, it's sold data, and we've had it out there for 10 years, 12 years to be downloaded. It does have a low impact, but they're not going to accept the fact that I'm going to call them up and say, hey, it's low. You've got to go through a standardized process in order for this to happen. And OCIO must make that determination. We're doing this on some of the other services and data that we have right now. This is a long process. Okay. So the storage solution provider that you ultimately end up with must have matching certification. So if you have a moderate potential impact, then that location must be FISMA moderate certified also. So OMB requires the government data to be stored at a certified location. Right now, there's only 3 of those. It's in Kansas City, one in New Orleans with NFC, and this is a new one that I just heard about this week. I'm putting this together is NASA. I have no idea where it's at. Probably doesn't matter. Okay. Why is this such a problem? The law requires each federal agency, USDA, EPA, DOD, Homeland Security, to have or develop documentation. Yes, if you went and searched on Amazon and Google, you would probably find someplace where it says that they're FISMA certified. But for what agency? Okay. Amazon did have that certification, but it was only one agency and only on one application, and that certification is now expired. I'm not sure what the time frame is going to be on the certification part of this. And we can't force the commercial solutions to become FISMA certified. Perhaps it's just not in their business model to jump through all of the hoops that we're going to require of them in order to be secure. Okay. There is something out there called FedRAMP, where they're trying to get a government-wide program to standardize how folks become FISMA certified. Okay. They're trying to get away from each agency having to do it. Yes, they're making progress, but it's just slow. We talked a minute about cloud services. So what is a cloud? Well, that's the use of hardware and software resources delivered over a network, usually in our case the internet. Most of the clouds are REST-based APIs. There's several types of cost models. Okay. Cloud services require storage pricing, data transfer pricing. So if we're going to transfer in new NAIP 2013 data, we're going to transfer in new LiDAR data because I said it was growing daily. You know, the data aren't static. Who's backing up the data? Are they backing up the data? Who patches for security vulnerabilities? In many cases, a lot of commercial solutions don't patch for security. This isn't an inclusive list of what the cloud services requirements are. It's just some that are off the top of our head. So a little bit of an exercise in numbers here. If I looked yesterday at the Amazon pricing, first terabyte per month, and you can see what the next 49 terabytes are going to be, 12 cents, 11 cents. NGMC pricing, 88 cents per month per gigabyte. 1 terabyte equals 1,024 gigabytes. So if you do the math, you're looking at $5,600 a year at Amazon, where we're looking at $43,000 a year for NGMC. 4 terabytes of NAIP per month, per year. So if I take 4 terabytes of NAIP, then the 4 terabytes of NAIP CIR, and the 6 terabytes of LiDAR data, and I'm in Amazon, I'm looking at close to $19,000 a year, as compared to $151,000 at NGMC. 14 terabytes isn't all of the data. That's just 3 themes that are listed there. This is only the storage cost, and it doesn't include the other ones. Just my disclaimer here, the prices change regularly, and these were accurate as I knew them as of today. They might be different tomorrow. Let's end this on a high note here about making a map from a service. So back in ArcMap, I have selected Add Data, and I'm selecting Add Base Map. In this case, I'm selecting imagery, and I'm going to click Add. This Add Base Map is kind of new in 10 and 10.1, and the base maps are supplied from SRI. Wanted to let you know that NRCS has purchased a lot of these base maps from SRI, and what we call it is the SRI appliance, or the ESRI appliance. I wasn't able to show you those right now in the services because we had to detach it, send it to Fort Collins for them to do a few things with, and then we'll get it back. Once you start traveling through all of the host URLs, you're going to find probably the ESRI appliance at some point. So I selected imagery, said Add, and this is what popped up. I turned on the boundaries, and I turned on the places, and I zoomed in while you guys weren't looking. This time I selected Add Data from ArcGIS Online. This is a service that ESRI has. I think you can sign up for a 30-day trial. They've started adding pricing tiers to it. Not sure what all that entails. I searched for soils, found something that says USA Soil Survey, and clicked Add. This added a soil service from Esri that displays the dominant order. I zoomed in a little bit more, and that last balloon over there on the right is the Fort Worth Federal Center, Building 23, where I'm at. That's how you make a map from the services. A couple of different things. If you have questions, go ahead and send them in the live meeting Q&A link. If you have questions later, email me, give me a call. Sean, I'm not sure where we are and if we have time.
Yeah, we're fine. Thanks, Jennifer. And it looks like there might be one question in the Q&A.
Yes. Let's see. What if you aren't using ArcGIS? I'm familiar with ArcGIS services as I used to work at ESRI, but I'm now working for a company that has GIS developed in open source. Can I still use the SCA Layer? The answer to that, provided by my panel here, limited availability of web map services and web feature services, open source services from NGMC, due to the fact that the NRCS audience has access to ArcGIS products. Servo is available as a WMS and WFF. I'm not so sure about the SCA Layer being available on NCGCWS for NRCS users. Soil's public servers are located on another server, so yeah, I have to get the address for that one. So we can also respond directly back to this person with a little bit more of an address.
Any other questions? All right, well, if there's no more Q&A questions, I'll thank everyone for their time and attention. And again, this webinar has been recorded, and once it gets processed, we'll post it online on our webinars, presentations, and training sessions. Thanks, everyone, for your time, and we'll catch you next time.